Welcome back to another video, and today we will talk about first three tasks of our function practice stack given to us by our AI manual. I've already played around it, and I should say that it was pretty fascinating. It's a lot of information. I've already explained my understanding of functions in Python in the previous video, so I guess that we can just get started. Our first task is to make up a function for counting the factorial of the number. What does it do? Basically, oh my god, what's going on? Okay. Um, Basically, it's not very difficult. Factorial is a number which is the multiplication of all the natural numbers before the one you want to know the factorial of. So basically, if you want the factorial of 3, you get 1 multiplied 2 and multiplied 3, and this is 6. Okay, now what do we do in here? We make up a function with the parameter of n, and you just make a list of all the natural numbers, including this one, from 1 to this one. Then you just add, then you multiply it, and you get the final result. So we start with 1, and then for each element in this list, we just make, we just take this and multiply it to the current element. So basically the next number, and we return it. So we ask our user to make it, and then we print the result of our function from this n. Let's just do it. Input the number, let it be 5. And the result is 120, which is perfectly correct. We can enter 3 and see that it is okay. It's surprising how these lines of numbers grow drastically, really. So when it's 3, it's 6. When it's 5, it's 120. When it is 10, it's this number. I'm not really sure that I can pronounce it. So it's 3,628,800. As you can see, that's a lot. The progression is interesting. So this was the task number 1. These tasks are not that complicated from the perspective of programming, but they're pretty complicated when it comes to math and logic. So it's a good training thing. Okay, number 2, make a function that's gonna check if the number is simple. What is a simple number? Simple number is a number that can't be divided with an integer at any of the numbers before this one, right? So if we get 1 can be divided by 1, but only 1, so it's simple. 2 can be divided either by 2, either at 1, so it is still simple. But when it comes to 3 as well, it can be divided by 2, right? So it can be divided only onto itself or 1. When it comes to 4, it can be divided on 3, but it can be divided on 2. That's the point. So it is not a simple number. The line of simple numbers is, as far as I remember, it's 1, 2, 3, then it's 5, 7, 11, 13, 17, and so on. That is the whole progression. You can look for the theory. I'm not really a mathematician at all, as you might have noticed. Our first variant of the solution is pretty basic. We make a checklist that's going to contain all the numbers from 2, because everything can be divided at 1, right? Till n, till our number. And we put our result variable at true. And then in a cycle, we check if it can be divided. And if it can, we print that it can be divided, and the primary, the first divider, we display it, and then we make it false and break. Otherwise, if there is nothing, we just continue. And if after all the iterations of this cycle we still have result is true, then we print that this number is a simple number. Pretty easy. Let's try 120. Oh, I forgot to decrement it. Sorry. Of course, it's not simple, and primary divider is 2, but we can try something like 17, for example, and it's a simple number. So as you see, it works perfectly. Now, when it comes to our second solution, it's a little bit different. It not only shows us if a number is simple, it also shows us the whole list of the dividers possible. So we make up the dividers list, and we make it using list comprehension, but only if it can, this number can be divided into this element. It's pretty similar, but with this condition, which means that this list contains only the dividers, and if the length of this list is 0, then it's true and the number is simple. Else we just give the dividers. Well, actually we don't need to return it, we just need to print simple. Let's try this one. Input the number 120, and as you see, these are all the numbers at which 120 can be divided as with the integer as a result. But if we place, for example, 17, it's simple, and it's none, yeah, because in here we don't return anything. So yeah, be careful with these type of functions, because I played around it and entered lots of different big numbers to check it. It takes some time for my computer to be able to process this all. Our program number 3. Make up a function that's gonna generate Fibonacci list. Fibonacci list. It will be pretty complicated for me to explain it. Fibonacci list, the primary elements of this list is 0 and 1, and each next element is so the third is the sum of first and second. The fourth is the sum of second and the third. The fifth is the sum of the third and the fourth, and etc. This is a solution I found out in the internet. To be honest, I'm not that clever. It's very elegant, it's very short, it's very neat. What do you do in here? You make some variables. You place default values for them, and then you start up a cycle for in range n. You yield a, and then when you yield it, you make it a list. After you yielded it, you make a equal to b and b equal to old a plus old b, right? You can pause here and try to think it through. It was pretty complicated. I almost broke my head trying to like think it really through. But I'll tell you how my program works, my own version, so it's gonna be not that hard. So number of elements, I guess 9 will be okay, and we have 0, 1, 1, 2, 1 is the sum of 0 and 1, 2 is a sum of 1 plus 1, 3 is a sum of 1 plus 2, and go further. So each works perfectly. It is an extremely elegant solution, but really my brain is not trained enough for making it by myself. Now, when it comes to my own version, it makes the primary list that contains 0 and 1, and then for I in range, starting with 2 till n with a step of 1, so each number starting from 2 till n, we make up a new element, and this new element is going to be the element that is previous one plus previous element, and then we append it, and then cycle begins anew. I was thinking about making it in a comprehended way, but I don't really know how to make it like this, how to work all this thing through. So if it is possible, let me know in the comments below, please. But as for now, it works like this, and we just call it. Maybe this looks complicated, but it actually is not, because first of all we need input, then we make it into int, so that is not string, it's an integer, so that we can calculate it and count it, and we then give it as the parameter to our Fibonacci function, and we make the list out of our Fibonacci function. I'm not really sure if we even need it. I guess we even don't need it. I just copied it. This line from this. So as it is a generator, we need to make it list. As it is the list, I don't really think that we need to do it. Let's try 8. Yeah, it works. It works perfectly. It works perfectly. And one more time, look at the progression. It's pretty fascinating. So when it's 9 numbers, it's 13 are not very nice growth. But when it comes to, for example, 30 items, look at the value of the last one. It's insane. You even can look at the progression in the number of digits in each element. It's really fascinating. It really fascinates me. So these were first 3 tasks from our function practice kit. I've already read all the tasks that we are going to do, right? But if you want, number 4, decorator for measuring the performance time. Number 5, function for working with wrapped lists. Number 6, function for validating email address. Number 7, function for working with dates. Number 8, function for encrypting the text. Number 9, function for handling the exceptions. And number 10, function for working with regular expressions. Basically, I guess it was a pretty long day, to be honest. So I guess it's okay. Thank you very much for watching this video. If you did, really thank you. If you have any suggestions, if you want some improvements, just let me know, please, because it's really hard to analyze yourself, and there are some things that you just don't notice. And really, even if you're a dabbler that doesn't really know a lot, but you keep pushing it every day, you keep pushing it regularly, you will one day achieve everything you are pushing. So keep working, keep trying. It's gonna pay back. Have a nice day. Bye.